Hi, I'm Randall Heyman, a university mathematics academic. During the coronavirus, I've been making quick turnaround videos to help students and educators during the virus. So if you'd like me to make a video for you, then just comment below any of my videos or drop me an email. Okay, so I got a comment below one of my videos from Alexander, who asked me a modular arithmetic question. Why no modular inverse if the GCD, greatest common divisor, does not equal 1. So the background to this is my video modular inverse made easy. So the question was, find the inverse of 197 modulo 3000. And it turns out that the GCD of 197 and 3000 does in fact equal 1, and so therefore there is an inverse. So for Alexander, what I might do is I'll just give you a sort of an example of why you can't get a modular inverse if the GCD is not equal to 1. So let's take, for example, if you had this, find the inverse of 6 modulo 8. Well, that means we need to find an x, I'll call it x, whatever, such that 6x is equivalent to 1 modulo 8. After all, that's what it means to be an inverse. When we multiply 6 by this x, we get 1. So therefore, well, one way to look at it is 6x, that stays, but I'll get rid of the modulo environment. And what does it mean for 1? If I say 1 modulo 8, well, that's the numbers 1 and 9 and 9 plus 8, 17. And if you go back, you'll get -7, ... So it's all the numbers. When we divide by 8, we get a remainder of 1. Well, those numbers are 8 times, say, t plus 1, where t is an integer. And so therefore 6x minus 8t equals 1. And now there's a problem. This is even. In other words, 2 divides 6, 2 divides 8. Or if you want, you could say it's even, the whole thing's even. And so if the left-hand side is even, well, right-hand side must be even. But 1 is not even. So therefore, impossible to find an inverse. So that idea we can extend. If you want to think about it before I go on to something more at the general case, I mean, if you like, note that 6x minus 8t must be divisible by 2 or 4 or 6 or, you know, ... So some multiple of 2. Let's just talk about it more generally. If you want to, Alexander, go into this in a bit more detail, more generally, let's look at this problem. Find the inverse of A modulo B. So, AX. There must be some X that, if there is an inverse, mod B. So what does that mean? Well, it's the same as I did before. AX must equal, let's call it BT, little t, plus 1. So I shouldn't keep writing. Plus AX minus BT equals 1. Now remember, A and B are the numbers we're interested in that we started with. X and T are just any integer. We don't really care. Now, recall, or you may not be aware of this at all. There's an identity called Bezout's identity, and it depends exactly what you regard as the identity and what you regard as flowing from it. But for these purposes, let's just say Bezout's identity says that all multiples of, say, A, big A, plus, it's actually plus or minus, I suppose, because the multiples can be negative multiples, plus all, oh, actually, maybe we should say any, that any multiple, if you take any multiple of A plus any multiple of B, the result must be divisible by the GCD of A and B. And this is actually exactly what we see here. We've got a multiple of A plus a multiple of B, we get 1. So what I'm saying is, I don't need that, it's from a previous video of mine. So Bezout says, what does it say, is that AX minus BT must equal the GCD of A and B times, I don't know, some constant. Yeah, we said that this must be divisible by the GCD. Well, that just means that it's the GCD times some constant. So, so now let's look up here. So comparing with that equation, well, 1 is equal to the GCD of A and B times C. Well, if 1 here is a multiple of the GCD times some number, well, that must mean, therefore, the GCD of A and B must equal 1. And more particularly, if not, then A will not have an inverse. Modulo B. Okay, so I hope that's given you a bit of an idea, Alexander, on how to do this. If you wanted, I think what I've tried to do is give you an example, a real simple example with 8 and 6. Then we've gone to the general case. I haven't done the general case like strictly formally. You could criticize it as being not formally exactly, well, not exactly a proper formal proof, but I think it'll give you an insight into how to look at this. If you've got any more questions, let me know. And more generally, if anybody's got any questions on mathematics during the virus, drop me an email or comment below any of my videos. Thanks.